好。Okay. Good morning. This should be good afternoon, everyone. Now, we finish all those book 1C, right? And starting from this week, we will start to have a mocale quiz. Okay, we have got over 10 versions. Okay, just double check if you have finished doing all those exercise. 做晒未？你記唔記得？You know that in the last 6 days we have got a daily challenge. 做晒未？ Now for those who have finished it, could you please put a tick? Let me know. Of course I know, right? I go before I turn on the Google Classroom, right, and show it to the public. You should know that I know it already. Now you would have the quiz in this week. Okay. So to start with, I would like to do you have book 2A today? Now, please spend 1 or 2 minutes to search your book. Okay, please search your book now. Book 2A. Now, in this week, before Chinese New Year, we will finish this book until titration, okay, which is unit 17. So which means that 16, 15, and 14 we will have a coverage on these 3 chapters before we end up the this one, okay? Before we have CNY, Chinese New Year holiday. Textbook 2A. Now, I would like to double check if you guys, all of you are here. Who is absent today? 得4個人剔咋，其他人未做晒。Now I'll give you 2 more days to finish them. And I would like to have the quiz, okay, from this week late. That will be probably Thursday. Okay, Thursday we have got the first quiz. I'll give you 2 more days to finish those missing parts. Thursday I will have a start on the quiz. Now, what I'd like to show you is on this. Do you have it? We come to acid and alkalis. Acid and alkalis. So to start with, in today's lesson, we focus on acid, first of all. today in this double lesson, we come to acid first of all. So acids, what do you know about acids? Now, acids, once you heard in Form 2, IS, you may have heard of that term. And indeed, acid is not just what you know it in laboratory, just like hydrochloric acid, nitric acid, sulfuric acid. It can be some other cases that it is commonly found naturally. Okay, you can find it in so many natural materials, and you may find that acids are around you. So I just quote some of the examples, and you can get what I mean. Now, for example, vinegar, right? It contains ethanoic acid, citric acid found in lemon and orange, and grapefruit. We call it citric. Okay, you see that the word citric, like monsoon. So why you say that? Because though what are they similar? You call it it's come from citrus fruit, 橘子類嘅植物啦。咁樣 so 為什麼係橘子 ？It seems like 柑、桔、橙、檸檬, all those they are just. And you may find tomatoes that contain oxalic acid. Similarly, can you give me one examples of the vegetables which contains oxalic acid? 鄭學明 Could you please quote for me and other examples, right? Of fruits. Ball choy, spinach. Yeah, spinach. Okay, it's also a vegetables containing full of oxalic acid. So yogurt, so we call that lactic acid, 乳酸. So you may find that soft drinks contain carbonic acid, toilet bowl cleanser we contain phosphoric acid, vinegar, as said before, ethanoic acid. So to start with, I'll give you 2 minutes. Please search on the web now and try to put down those formula of those acid and put it next to the name. Do it now. I give you 2 minutes. Please try to find those. For example, ethanoic acid, I find it as CH3COOH. Do it now. I'll give you 2 minutes. Okay, for those who have got a pen, you may write it on the screen as well to let some others know that you have got the answers.李澤星大筆一揮啊！ Yep, you may find it as H2CO3 for carbon acid. Yes, that's right. Now, lactic acid, you write down as C3H6O3. Spinach and oxalic acid is C2H2O4. C6H8O7 for citric acid, H3PO4. Yes, that's right. Correct. But you may find the form is quite different. Now, for example, if you say phosphoric acid, it's quite common to write it as H3PO4. Carbonic is H2CO3. But for the citric acid, oxalic acid, lactic acid, and even if you want to talk about vinegar, the way to present the formula is different. How different it is? For vinegar, I write as CH3COOH, even for ethane acid. Indeed, if you search it on the web, you may have got so many different ways to represent this formula. Okay, it's not just CH3COH. It can be something like this: CH and then H and then C double bond OOH. Can you see that? Can you see something like this? Now, similarly for oxalic acid, could you please do the same by searching this for oxalic acid? What is that? How we call it? We call that ethane dioxide. Now with the structural formula, now we call that structural formula. As this, right? So tell me, what is that double line or the single line? What is that?
Single bond, double bond.
Yep, single bond, double
Covalent bond.
Single covalent bond, double covalent bond. Okay, just recall your memory. How about yogurt? How about yogurt in a lactic acid? Can you draw me the structure of this, the structural formula? What is that? It's not just this. It is very, very strange. C3H6O3. What is that? We will write that down as C double bond OOH. Okay, for this, the other one with C here and then OH. We have got one for that, it is CH3. The last one is that, such that you may find that it is C3O6. Okay, is that 6O and 3O like this? 6H and 3O. We call that lactic acid. And how about the citric acid? It's more complicated. Citric acid, if you search on the web, so what is that? What is that structure? Yes, a very strange structure. We will have got this C and then OH, and with that COOH, and we have got this CH2 and then COOH, and another one is just CH2 here, and then we've got a COOH. Can you see that? So that we would have it C6H8 and CO 7O. So what are they in common? Now what I just circled, we call that as a organic acid. 有機酸. So what is meant by 有機酸? It is we need to come up with the term organic. Okay, organic in the past we would say that it is from something in organisms, living things. So we call that organic substances. Nowadays, you may find that it's not just living organism. They will have a chance of getting that compound. Indeed, you can also produce it by your own. But we still need to borrow this very, very old name, very traditional name, to collectively tell those type of organic acid. Now, what are they in common about organic acid? In the structure. 有冇咩有共通點㗎? We should make it as an acid.
都有 hydrogen 咯。
Yes, hydrogen. What else? If I say that it's hydrogen, how about water?
It has carbon.
Yes, it has carbon. Yeah. How about water? I've also got hydrogen. Anyone who can tell? 除咗有 carbon 嗱 carbon 啱嘅係咩嚟嘅 ？Because of carbon, I would say it as a type of organic compound。有機嘅化合物咧，佢哋啲樣咧就係有碳嘅，有 oxygen 喎。咁 water 就係啦 ，O2 就係啦。咁點解唔係叫 organic acid 咧？嗱，留意下有冇啲特別嘅地方？嗱，唔係逐粒逐粒 element 去諗嘅，你可以諗咩咧？我哋一堆堆咁諗嘅。What is in common? For example，
CH 同 O 啊。
CHO all together. Now, how about the connectivity of atom? How do we connect it? Do you realize this? COOH. Now, how about this? Can you find that similarly in citric acid? Yes, that's right. COOH. Because I write from the right hand side to left hand side, so I write in reverse. COOH, COOH. And for spinach, ethanoic acid, it is COOH. Can you see that? And also this one, COOH. So that's why you may also find oxalic acid having formula COOH and then bracket 2. And lactic acid, it will have got another COOH. Can you see that? So what are they in common is that we have got that COOH, it is a common groups of atoms. We call that functional group. 官能基. So what are they in common is that they would share this type groups of atoms connected like this way. The carbon connected to one for oxygen by double bond, the other O by single bond. While the one which connected with single bond O, they would further connect to another hydrogen. So we call that COOH. Do you understand? We got COH. So, however, while you talk about some other material, just like toilet bowl cleanser, you may find phosphoric acid as well as what? Hydrochloric acid, sulfuric acid, nitric acid. What are they then called? We call that mineral acid. Collectively, we call that mineral acids. Okay. Why? Because it is the structure of it seems like minerals. Okay. Why is it that it's very similar to minerals? For example, sodium chloride. Now we have got part of them. It is chloride ion. Okay, sulfur acid, sulfate. For example, sodium sulfate, sodium nitrate. Now all those they are just telling while the form is very similar to the minerals, so we call that mineral acid. Okay, can you get a point? That they are derived from the minerals. And what we just mentioned, for those having COOH, what we call that? Organic acid. Why? Because traditionally, they were once found inside those living organisms. So we call that organic. 分到有咩分別啊? Now, take a look on the structure of this. For the mineral acid, do they have any COOH? No. Is that we would have just hydrogen here, and then hydrogen here. Can you see that? Just H, one H. Very strange. So this we will call that a type of an acid. Do you understand? So, if you take a look on the properties of acid, you may heard of that. For example, they are sour. Okay, but if you want to talk about something more about chemical property, now this is somewhat that you need to know. 化學特性啊，it's not just sour taste and pH smaller than 7. Okay, so you may have of the chemical properties, and something more called as the physical property. Now in form 4. Now, for example, this is physical property, this is chemical property, and this is chemical property, and this one is chemical property. So that's why you need to get to know something more about that. Okay? Do you understand? 呢個就係我哋所講嘅特性啊！我哋唔係淨係要知道係酸啦，pH 細過7嘅。We try to get to know more about the electrical conductivity. They are reactive to metals, base, metal carbonate, and hydrogen carbonates. Okay, is that clear? All right, so we come to I'll try to see if you can see the experiment video. Sorry to say that we cannot do the lab. So sad. So I would like to exemplify by using this one, hydroxide. Do you find it? I'll try to see if I can have the sound here. This one. Have you all seen it? Watch it.
In this experiment, you are going to investigate the properties of dilute hydrochloric acid. Pour 4 cubic centimeters of dilute hydrochloric acid into each of 3 test tubes. Add 2 drops of litmus solution, methyl orange and phenolphthalein into each test tube separately. Record your observations. Litmus solution in dilute hydrochloric acid appears as pink. Methyl orange in dilute hydrochloric acid appears as red. Phenolphthalein in dilute hydrochloric acid appears as colourless. Clean a piece of magnesium ribbon by using a sandpaper. Put the cleaned magnesium ribbon into a test tube containing 4 cubic centimeters of dilute hydrochloric acid. Trap any gas given off by putting an inverted stopper over the mouth of the tube. Use a burning splint to test the gas given off. A pop sound can be heard, which indicates that the gas given off is hydrogen. Put 1 spatula measure of sodium carbonate in a test tube. Add 4 cubic centimeters of dilute hydrochloric acid. Quickly stopper the tube using a stopper fitted with a bent delivery tube. Pass any gas given off through lime water. The lime water turns milky, which indicates that the gas given off is carbon dioxide. Put 1 spatula measure of sodium hydrogencarbonate in a test tube. Add 4 cubic centimeters of dilute hydrochloric acid. Quickly stopper the tube using a stopper fitted with a bent delivery tube. Pass any gas given off through lime water. The lime water turns milky, which indicates that the gas given off is carbon dioxide. Add a small amount of magnesium hydroxide into a test tube containing 4 cubic centimeters of dilute hydrochloric acid. Use a glass rod to stir the mixture. Magnesium hydroxide dissolves in dilute hydrochloric acid, forming a colourless solution. Add a small amount of copper 2 oxide into a test tube containing 4 cubic centimeters of dilute hydrochloric acid. Use a glass rod to stir the mixture. Copper 2 oxide dissolves in dilute hydrochloric acid, forming a blue solution. Place 30 cubic centimeters of dilute hydrochloric acid in a beaker. Set up the circuit. The light bulb glows, which means dilute hydrochloric acid can conduct electricity.
Wow, so overwhelming, right? We have got so many different properties that I've mentioned in this video. And it's time to record your memory about this. We have, what is the first series of tests? I add some first change solution. Do you still remember? 考下大家啲記憶先，短期記憶。
Phenolphthalein.
Yes, phenolphthalein. What is that?
Litmus.
Yep, litmus solution. What else?
咩 methyl 做咩 orange？
Yep, litmus solution. Methyl orange. Okay. Methyl orange. 甲基橙。phenolphthalein. So what are they collectively called? Do you know what are they? What is the use of these three chemicals in our school lab? What is that? 石蕊溶液啦，甲基橙啦，酚酞啦，咩㗎？ So what are they collectively? We call that a type of an acid alkaline indicator. So could you please give me one more example of the acid alkaline indicator used in the lab? The one that you may know it in Form 2. Yeah.
Universal indicator.
Yep, universal indicator. Now this is a simpler version of the universal indicator, I must tell. Now, universal indicator, you may find that we have got various color in different pH range. They've got different color, right? So you cannot tell actually we have got so many different color, more than 14 I must tell. Okay, however, if you want to put this litmus solution, methyl orange and phenolphthalein, it is simply a version in which they will change its color in different pH. Okay, simply speaking, for litmus solution, what is the color? Now, litmus solution comes from the word litmus paper in Form 2. So what are they in common? Is that the dye inside is the same. Dye, 染料. So the dye inside they are the same, but the way to put it is different. The litmus paper, if it's blue or red litmus paper, is done by what? Having a red litmus solution, I put a piece of filter paper strip and then take it out and let it dry. It's very simple. Okay. So this is what we will call that a litmus. So it originally comes from the word litmus. It is come from the dye in lichens. Do you know what's that? Do you know what's mean by lichens? 知唔知咩㗎? The one you may find it onto the countryside. We have got something like mold, right, on the wooden branches, right? But indeed, it is not mold. It is something very, very good. Do you know it? Lichen, do you know what's that? Yes, that's right. It's
哦，即係
that.
嗰啲咧樹上面嗰啲一嚿嚿嗰啲。
Yes, yes, that's right. So for example, if you even though in the town, right now you see the branches, we have got some green patches here. So it is not a sign of rusting. It is not a sign of rotting plants. It's a sign of to tell you the air nearby is very, very clean and fresh. Okay, it's a very good indication to tell you the air quality nearby. In the heavily polluted area, of course, you don't have it. 地衣有冇聽過？地衣 So it is a very good indication to tell you the surrounding environment. What is that? Okay, so I extract one type of lichen, then we have got some limits. 有啲植物染料嚟㗎，其中一種嘅地衣咧入邊就有呢啲頭先我所講嘅一啲嘅 limits 啦。咁佢哋咧轉色嘅地方咧好特別嘅。So we have got a very special working range of limits. Okay, working range. All of you, could you please mark it down? Working range of limits. Once you write down the working range of this, you can get what I mean. Now you would search on the web, okay, and you would have these, something like this, right? So you may have got so many different types of common, yeah, that's right. Libuhan, you want to say something?
I only press wrong, sorry.
Press it wrongly, it doesn't matter. So you may find that indeed methyl orange, phenolphthalein, can you see that? And it is also a type of a common indicator. Now you would change its color, but the color of that is not so varied. But when you compare with universal indicator, for universal indicator, it seems like rainbow color, right? From the red, orange, yellow, green, blue, purple, right? From acidic to alkaline. And in between them, there may be slightly orange, red, orange, yellow, right? So that's why I would say that the color is varies, right? It's various. So you may find more than 14 colors, I must tell. But for the methyl orange, can you see that? What is the color change? The color change occurs at 3 to 5, is about orange, but below pH 4 is just red. Larger than pH 5, it is yellow. How about phenolphthalein? Below 8, it is colorless. Above 10 pH, it is red, while in between 8 and 10 is pink. Can you see that? How about limits? How about limits? Do you know? For the limits, it is that this is what I would like to graphically show you. That what does it mean by that? Okay, so in between here, it is the mixing of the two. So red plus yellow equals orange. Colorless plus red equals pink. 就係咁啦，寫翻晒未？嗱，寫翻晒落去本書度啊，因為我哋遲下我哋都要記得佢哋嗰個working range 嘅，即係呢度。So you may find a limit solution. How about limits? It will having pH 5 to 8, it is purple. Greater than 8, it is blue. Smaller than 5, it is red. Now that's why I would use litmus paper. Red litmus paper, why you say that you test it for alkaline, right? Something like this. While the blue litmus paper, why is it can be used to test for acidic, but not red litmus paper is because of the change in color, right? That will help. Methyl orange, pH 3 to 5 is orange. How we make it orange is from red and yellow that get mixed. So we have gone in between, it is orange. Phenolphthalein is colorless, very strange case. Colorless for pH smaller than 8, 8 to 10, it is in pink. If it's highly alkaline, it is red. Now all of you please mark it. Now, so don't worry. If you miss it, you may use something similar, just like Mr. Chin. You go to the web and then search it, working range. working range of something and you can search. Can you get the point? Okay. Now, this is the first part. Any questions so far? Now, we come to the second part. It's about the electrical conductivity of the acid. Indeed, it is an electrolyte, 電解質. Why you say that it's 電解質 but not an electrical conductor? 頭先有冇留意到個實驗入邊有啲咩咁特別嘅地方？ Now you just open it, right? Enlarge the diagram.
有啲泡。
Yes, there are some bubbles. There are some bubbles. So what is that? A sign of chemical decomposition. There is a sign of the chemical decomposition. 有啲化學分解啊。So, and this is that's why we call that an acid a type of electrolyte, but not an conductor. It conducts electricity. But how come it conducts electricity? It's because of the term mobile ions. So what mobile ions are there? Now you may guess. For example, HCl. What mobile ions that are found here? You got hydrogen ion and chloride ion. How about sulfuric acid? What we find is hydrogen ions, sulfate ions, and partly we have got hydrogen sulfate. Okay, mainly at first, mainly. Okay, what else? Now I would like to design an experiment to show the electrical conductivity by glowing a light bulb. Okay. So it's a very authentic experiment to tell. But now remember, we focus on the conductivity, but not the decomposition, right? But you know it later while you talk about electrolysis. Okay. How about this reaction of metal? Now, can you see that? Very strange. Reactive metal. Now, but not all metal. Can you see that? They can only react with metal above hydrogen in the reactivity series. Okay. What happened if I put the metal just like copper into dilute acid? No reaction. All of you, please mark it down. For example, for copper, no reaction. But for calcium, yes. How about potassium? Sodium, yes. But very explosive. So never put the acid to the piece of metal. It's rather dangerous. So, and second, take a look on the acid. I mentioned it as dilute hydrochloric acid, dilute sulfuric acid. How about dilute nitric acid? No. It is another case. Now, we do not mention it as dilute nitric acid. We will say that it is a mild oxidizing agent. So even the reactor just like copper can also react. For example, copper can also react. So only very dilute nitric acid, they would react it normally. So all of you, could you please mark it down? So 3 cases: dilute hydrochloric acid, dilute sulfuric acid, very dilute nitric acid that can react. It's commonly. Okay. So simply speaking, what is that? I know that hydrogen gas, by putting a burning splint near the test tube containing the gas. And what is left behind in the solution is, we call it as a salt. So remember, salt is not just sodium chloride. Now, it really depends on the nature of the acid to tell you what salt it is. Now, for example, if I put it as a piece of metal sodium into hydrochloric acid. Now, if you can control it very well, of course, you can get sodium chloride solution together with hydrogen gas. Okay, now, but I change it like sulfuric acid. The salt is not called chloride, we call it sulfate. Okay, you see that? Sulfate is the metal, the whether or not what is that salt form comes from the acid. Okay, you see that? So it's hydrochloric acid, we call it chloride. Sulfuric acid, we call it sulfate. How about nitric acid? We call it nitrate. For example, calcium plus nitric acid. So what we get? We call that calcium nitrate and hydrogen gas. Can you get a point? So simply speaking, you may have this NO3 and NO3, they are common, right? Which will tell that the salt form, half of them comes from the acid. Okay, how about cation? Of course, it comes from the metal. Now, this is what I would like to draw attention. Is about how about unreactive metal, just like copper. Now, such as copper, silver, gold, they do not react with both dilute hydrochloric acid and dilute sulfuric acid, and also very dilute nitric acid. No such reaction. So this is what I would like to remind all of you, right? This questions. Now, how about base? What is mean by base? The reaction of base. I just mentioned the two types of base in the video. One is copper oxide. The other one is magnesium oxide, right? Just remember. What is mean by base? Base is a substance with which will react with the acid to form salt and water only. 鹽基. We call it 鹽基. So, of course, what is that? We call it a type of neutralization. 中和作用. The whole reaction, we call that a neutralization reaction. So remember, only that type of something saying, just like metal hydroxide or metal oxide, it is type of what we call a base, react with acid. They will call it to form salt and water as only product that will record it as a neutralization reaction. Now, copper oxide is not soluble in water, but we react with dilute sulfuric acid. They will form copper sulfate and water. How we know that there is a reaction? First of all, the solid dissolves. Second is about the color of the solution. Okay, you see that? It turns blue from colorless. Originally it's colorless, but it's now changed to blue. While the blue solution comes from the presence of copper ions in solution, right? So this is what I would like to remind all of you. And similarly, if I change it to hydroxide, so what are they in common is that they will form water as a product. But how about the other one is zinc chloride, right? So you may merge together from zinc chloride. Now take a look and do the same thing, right? The copper sulfate for here. And you just add another color pen to tell oxide hydrogen ions to form what? Water. Can you get the point? Can you get my logic, right? And similarly for this, right? You may see iron sulfate together. Lithium here is hydrogen, right? I do hope by doing so you can memorize those equations more easily. Questions? Now, similarly for metal carbonate and hydrocarbonate, they will say that they will react to form salt and water, but also carbon dioxide. So this is somewhat very different. So that's why it is not set as a neutralization reaction. Even though the acidity of the acid is lowered by the presence of carbonate and hydrogen carbonate. But according to our definition, this type of equation reactions, we not call it as neutralization, because carbon dioxide will also be formed besides salt and water. And we will have the case, a very authentic example, form 3IS, calcium carbonate react with hydrochloric acid to form calcium chloride, H2O, and CO2. Now, how do we present this? As I said before, calcium chloride. And leaving behind, it seems like carbonates react with hydrogen ions to form carbon dioxide and water. Okay, so if you refer to the observation, we will call that effervescence. Effervescence. Now, this is somewhat a very special case. So to tell you something like a coating effect, okay, is that a coating effect? So all of you, please write down coating effect. That you mentioned something like this. And how will you know that the gas is carbon dioxide? A very traditional way is to bubble it into the gas into lime water. Why can't I? It seems I cannot. It seems I cannot draw something. Wait for me. Yep. Is it better? I'll try to do it here. Yep. Bubble the gas through lime water. Okay, bubble the gas through lime water. If the lime water turns from colorless to milky, we will say that the presence of carbon dioxide. But of course, if you bubble the carbon dioxide for long, excess, so the milky solution will turn to colorless again. So it's a very good that two equations that you know in form 3IS, I change it to chemical equations. Please memorize this. Let's start here. Now, sodium hydrogencarbonate reacts with dilute sulfuric acid to form sodium sulfate. Now, so you may see that sodium ion sulfate. So we will call it sodium sulfate. Okay. So in short, it's not just carbonate that react with acid, but also hydrogen carbonate. But the chemical, the salt form really depends on the nature of acid, the anion of it. They would determine the real name of the salt. But what are they in common is that they would form carbon dioxide and water as the common product. Questions? Now, in short, what we know about today is about the chemical properties of the dilute acid. Remember, dilute acid. So one more case I've just mentioned is the very dilute nitric acid. It is also the third case that will show a very typical acidic property. But other than those other examples, just like concentrated sulfuric acid, concentrated nitric acid, or even dilute nitric acid, is not a typical acid. So the behavior is a little bit different. So you'll know it in red dots later. So focus on that three cases first. And what we mentioned is on the equation, the reactions. They are collectively separated into three types. One is the reaction with metal. Remember, not all metal will also react with dilute acid. Only reactive metal can. So which means that from potassium up to which metal, they can also react. The one before copper, which is lead. Do you still remember? From potassium to lead, they can react with acid. dilute acid. But of course, for potassium, sodium metal, we never attempt it in the lab because it's too dangerous, too vigorous reaction. To form salts and hydrogen, I test the gas hydrogen by burning split. You give a pop sound. Second, the reaction with a base. What is meant by base? As said, it is a type of metal oxide or the metal hydroxide. What are they in common is that once we react with dilute acid, they will form salts and water. The third case I would like to share with you today is on the reaction with metal carbonate and or hydrogen carbonate. So what are the in common is that it's not a neutralization, but they will form carbon dioxide as well. So no matter it's hydrogen carbonate or carbonate, they will also react. Is that clear? Now we have got about 10 minutes left. It's time to refer to the class practice here. Do it now. 1 and 2. Okay. 1 is somewhat basic. State the products. Second, write the chemical equations. And the third one that I can do with all of you is on writing the ionic equations. Your old friend. Do you still remember your old friend? Ionic equations. Now, for example, I do it. The first one is example. The first one, iron plus hydrochloric acid, what will we form? Iron 2 chloride on the hydrogen gas. Okay, can you get the point? So if you want to write down the chemical equation for A1A number 1, it's iron hydrochloric acid to form iron 2 chloride plus hydrogen gas. What is mean by ionic equation? Is full equation. How about ionic? Do you still remember? Iron reacts with what?
H.
Hydrogen ion, not H plus. H plus. Hydrogen ion to form what? Iron 2
Fe2 plus AQ
and
plus hydrogen gas.
Yep. So remember the spectator ion is chloride ion. You need to kick them out. Do you still remember? Get off. Now you try to do part B and number 2 and number 3. Lime water plus dilute hydrochloric acid to form what? How you know what is lime water? It's so strange to write it in the chemical equation like this, right? Instead, I would write it as calcium hydroxide solution. It will help, right? So once I write like this, you can make a pairing up of those. Calcium chloride. So what else? What's not written? Hydroxide with acid, hydrogen ion to form water. So that's why if you want to refer to the blackboard again, I write down full equation. Calcium hydroxide and hydrochloric acid. So you may find 2 here, and you may find calcium chloride and water, 2H2O. So what are the in common is on this part? Calcium chloride, just like this one. Iron chloride, iron 2 chloride. Can you get a point? And we change it to ionic equation. So what was that? What is that? Forgot? 係咩㗎？應該冇人答喎。第三個 magnesium carbonate, we have the dilute hydroxide. What will we form? Magnesium chloride, carbon dioxide, and water, right? It is the product. Magnesium carbonate, hydrochloric acid. So it's full equation. How about ionic equation? Why?
Because MgCO3 is in solid state and all of the
Yep, the
fluorine
magnesium
and
carbonate.
spectator ion.
No spectator ion. How about
Yeah.
hydrochloric acid?
chloride 好似係 spectator
Chloride.
嘅
Right.
Yes,
Hello.
this one is a strong acid, so you can kick them out. Okay, so you may write it as 2 hydrogen ions to form what?
Magnesium.
Ion.
2
Okay, and CO2 and H2O gas. So you this one is very strange, where you may find this one magnesium chloride, right, as this, and leaving behind we will have that carbonate. We have a hydrogen ion to form carbon dioxide and water. So you may find that carbonate, hydrogen ion, carbon dioxide, water like this. How about the second case? What is the ionic equations?
hydroxide ion 好似流嘅。
Hydroxide ion plus hydrogen ion become water.
Okay, hydroxide ion and hydrogen ion to form water. But you may find it as 222, right? So what should I do? Cross them out. Yep, simplify it. And you change it as hydroxide ion, hydrogen ion to form water. So this is what, as a practice of writing full equation and ionic equation. Any questions so far? Now the last one. Now, can you do it now as well? What is mean by the name of the acid A? How do I know the name of acid A?
dilute sulfuric acid 咯。
How do you know it's dilute sulfuric acid? From the name of the salt. Can you see that? I write in sulfate, right? So of course, no sulfate originally, right? So of course, if you have got sulfate here, the acid is dilute. We'll call it a dilute sulfuric acid. Remember, you need to put the word dilute here. Okay, as said before, if I change it, the concentration to concentrated, for example, the chemical property may change. So you better keep safe, play safe by writing it as dilute sulfuric acid. How about B and C? What is a gas B and C? Metal with acid to form.
hydrogen gas。
Yep, how about C?
C 係 carbon dioxide。
Yep, carbon monoxide. How about colorless solution D? So you better mark it here and let you know beta.
Sodium
Yes.
sulfate.
Yes, that's right. So do you realize that when you tackle this problem, to me, Mr. Chin, I would love to write the chemical formula as well, because I use the similar logic, right? You can solve the whole questions very easily. It's simply done by underlying this, right? Sodium and sulfate. Of course, it's sodium sulfate. Can you get a point? So color solution is sodium sulfate solution. How about the black solid E?
Comparative oxide.
Yep, good. Except before, how we know this carbon oxide? How?
Blue solution.
Yep, blue solution. There must be some ions with blue. Right? There's some blue ions, so it is copper 2. No other cases, right? It's copper 2 ions. But of course, why is this sulfate? It's because of the acid is sulfuric acid. So N ion comes from the acid part. So of course, this one is sulfate. Copper 2 sulfate solution. And here comes solution F. How about black solid E? What is that? This one's difference F. How about E?
Copper 2 oxide.
Yep, copper 2 oxide. Can you get a point? Now, lastly, is on the identifying gas B. Gas B, how you test it? Gas B, you know it's hydrogen gas. The whole procedure, the full procedure, should know it, right? And remember to put it as observation as well. What are they? Put
a burning split near the test tube containing gas B.
Yep.
If the gas produces a pop sound, it is hydrogen.
Yep, that's right. So remember, you need to have some keywords, pop sound. Procedure, you need to have the word burning splint. So remember, you need to put near the mouth of the test tube containing the gas. Remember not to put inside the test tube. It's just near the mouth of the test tube. Never put it inside. Otherwise, the fire will pull off. Okay? Is that clear? So here comes the final. Today we focus mainly on the chemical property of acid. What do you feel about today's lab? Today's lesson? Easy, difficult, or what? No. Nine seven nine 876 8.56. Okay. 鄧浩俊、黃奕朗, you better read the book again. 陳樂嘉, you want to ask something? 麥嘉樂，學校人。Okay, nice. Now you better refer to the book and read it again. We have got so many different examples like this. Okay, and most importantly, go home and finish your vocab exercise first. Okay, we'll have a quiz very soon, later this week. Okay. For those who have got questions, you may stay behind and ask. For those who don't have it, you may now leave. Bye bye. Bye bye, 鳳寶。有咩問？冇嘛？冇啊，食飯咯喎。1、2、3，係問。
我想問下，我純粹想問下咧，咁點解佢個 pop， 即係佢點解放，即係佢個 hydrogen gas 放喺即係你個 burning split 嘅時候，佢會有 pop sound 嘅，即係個 pop sound 點樣嚟嘅？
好，之前咧有講之前咧我講過咧話呢度有如果 collect 咗啲 hydrogen 喺度啦， 咁你 burn spin 咧應該放呢度嘅。咁個火咧就喺度嘅。咁咧就做咩咧？就係你要製作緊咧一個叫做燃燒啊，呢個反應啊，燃燒啊。咁燃燒需要啲咩？有燃料先啦，跟住仲有啲咩
？Oxygen。
oxygen 啦 ，oxygen 喺邊度嚟啊？空氣度咯。咁火嗰個咩㗎？就係我哋所講嘅 high temperature 啦。咁所以咧，有一嚿兩二三咧，咁其實咧個火就會喺度發生啦。呢度有個火啦，係嘛？呢度有個火啦。好啦，咁要有火嗰陣時咧會點咧？由於咧呢一度一點着個火嗰陣時咧，佢會釋放好多熱噶嘛。咁所以咧連帶啊，佢一早變咗水嗰陣時咧，佢連隔佢呢度咧啲 oxygen 咧，佢自然就會就咁抽入去。咁你燃燒咗啲氫氣變水咧，佢就會變咗水珠啦。但係啲原本氫氣聚集嘅地方咧，就冇理由真空噶嘛，咪變咗負壓咯。咁你嗰啲空氣咧、氧氣咧就會走咗嚟埋呢邊，繼續咁樣同佢 react。咁所以咧，你會試下你做 pop sound test 好特別嘅。一開始個火喺度，但係咧原來個火咧會蔓延到成支 tube 咧，你會啲火咧咁走落去嘅。見唔見到啊？第二咧就係、當我做咗呢樣嘢之後咧，會有聲嘅。點解會有聲啊？因為咧佢有一個氣壓嘅驟變啊。氣壓嘅驟變咧，似乎係似咩？就似好似揸住嗰個嘅一支玻璃 tube 咧，你有冇試過吹啊？喺個嘴嗰度會吹啊。咁吹嗰陣時，其實你都係做緊一啲氣壓嘅一啲聲量氣嘅改變咧，從而會有啲共振嘅現象。其實我哋做緊係類似嘅嘢，所以咪 pop 一聲咯，得唔得？一急速嘅氣壓改變，咁導致到呢度咧係會有即係嗰啲玻璃瓶咧，呢個玻璃棒咧入邊係有共振，個 test tube 有共振，所以咧令到會有一下聲咯。但係一算式細啫，因為入邊氫氣咧俾你燒晒啦，燒晒就冇噶啦，所以咪聽到 pop 一聲咯。逢親如果入邊有氣體爆炸咧，嗰陣時我哋都會咁噶，就係入邊 pop 一聲嘅，就係原因就係咁啦。尤其是個空間係越細嘅話咧，就呢個 pop 一聲咧，嘅聲咧就會越尖聲嘅。如果有做過info day 嘅人咧，應該知啦。如果我整個空 nickel flask，我整啲酒精，可能又玩嗰啲實驗啊嘛。呢度整啲酒精嘅氣體，跟住就話又係攞個 burning spin 走去燒嘛。跟住咧就會有藍色嘅火咧，就由呢度燒到成個都係噶嘛。其實佢有冇聲㗎？有聲㗎，係個聲係比較沉啲嘅。點解？因為入邊嘅 container 個 volume 咧比較大啲。咁所以咧，如果令到佢有短暫嘅共振呢個現象嘅話咧，個聲音走出嚟個頻率咧係比較低啲嘅。咁頻率低啲嘅聲音，頻率低啲咧就係話俾你聽咩啊？就係啲聲沉啲咯，低音啲咯，得唔得？咁所以第一樣嘢啦，要知嘅就係 burning spin 點解呢一度 mouth 唔係 inside the test tube， 就係因為我要有氧氣，氧氣要喺個 burning 個 stopper 出邊嗰度揾到嘅。就唔喺個支 tube 入邊嘅。第二嘅就係點解會有聲 pop sound？ 我係短暫做一個爆炸，從而做啲咩咧？從而咧係令到入邊有一個好短暫嘅氣壓驟變，就好似我哋吹奏一啲樂器嗰陣時，我哋會有發出嘅聲響就係咁啦。但係好短嘅啫，所以咪聽到 pop 一聲咯。有冇嘢問？豆樽。冇啦，OK 唔該。好，明啊嘛，明啦。即係嗰陣時由細到大唔知係咩事嘅，總之背咗佢啦咁樣。係啊。咁今日講起 OK 啦，下次留意下。係啦，平時做實驗觀察多少少呢樣嘢，係好得意嘅。OK，有咩嘢問？冇就完咗咯喎。好啦，食飯啦，好啦，拜拜啦。